The nuclear atom. J. Thomson in the 1890s discovered the electron and came up with what is known as the plum pudding model of the atom. This consisted of zero density positive charge balancing out the negative charge of the electrons. Rutherford carried out an experiment to look into the structure of the atom. He had a very thin piece of gold foil, some polonium inside a lead box, and this fired out alpha particles towards the gold foil. To give a narrow beam, he had a lead sheet with a small hole in it in front of the lead block. The whole experiment was carried out in a vacuum because alpha particles can only travel a few centimeters in air. A microscope was able to move round at different angles around the foil in the path of the alpha particles. This had a fluorescent screen which gave a flash of light every time an alpha particle hit it. They were able to measure the angle theta at which the alpha particles were given off and count the number of flashes on the screen, the number of alpha particles detected, over a given time. This experiment was devised by Rutherford but was actually carried out by Geiger and Marsden in 1909. They found something like this. This is the gold foil, and these are the paths of the alpha particles. They observed that most of the alpha have little or no deflection, but around 1 in 8,000 are deflected through more than 90 degrees. The conclusions were that most of the atom is completely empty space, but the atom must contain a small, dense, positively charged nucleus with the negative electrons around the outside. This nucleus must contain most of the mass of the atom. If the atom just consisted of zero mass positive charge and tiny electrons, the alpha particles would just push straight through. They would not be deflected through large angles. So here we have nuclei, and the alpha particles can pass close to the nucleus and be deflected, or they can pass between nuclei and be virtually unaffected. By analysing the number and angle of the deflected alpha particles, Rutherford was able to estimate the size of the nucleus. With higher energy alpha particles, the observations no longer matched the Rutherford theory. The alpha particles were then getting so close to the nucleus that the strong force was being felt. This showed that the nucleus was around 100,000 times smaller in diameter than the atom. The model was refined by Bohr to give the electrons in clearly defined orbital shells around the nucleus. So we had a small, dense, positive nucleus with the electrons in orbits or energy levels around this nucleus.